So this is a trusted firmware tech forum, currently going to be presented by Raghu, and handing it over to you.
All right, thank you. Hi all, my name is Raghu and I work at NVIDIA as a platform security architect. And today I'd like to present you something that we've been working on with a few folks at ARM and with a few folks at NVIDIA. And that's enabling, VHE support in Hafnium so that we can run secure EL0 partitions on ARMv8.1 plus systems. This sort of an outline of the presentation. I'm going to give you some requirements, that's driven by, it's an ARM server centric view of what we require typically in secure world. And then, quickly jump to the solution that we think is correct. And we think, we believe FF-A secure EL0 partitions is the right solution to, or one of the right solutions to meet the requirements that I'll put forth, right? And then we'll explore pretty much all the, we went through a few different options of how we can meet these requirements, and we'll go through pros and cons of each of those solutions. And then I have a proof of concept that I've pushed upstream, and it's slowly beginning to merge into Hafnium mainline. And here I'll show you what the status of it is and some of the issues. And then we'll go through takeaways, right? Broadly, the goal is for everybody to take away that enabling secure EL0 partitions on Hafnium is an important tool to have, right? It's not to say other solutions are not possible or this is the only solution, right? So that's I hope that's the takeaway, and I hope the we say that okay, it's good to have this support in Hafnium. So now moving on, and feel free to stop me anytime if you have questions. So the requirements that I have is mainly driven by data center environments on ARM SoCs, right? So there's an incumbent chip maker who has set the bar for how data center looks like, and a lot of things are driven because of that, right? And these requirements are what the requirements would be in secure world. In an ideal world, I wouldn't be talking to you about any of this, and there would be no code in secure world other than say PSCI and a little bit of EL3 firmware and PSCI, right? And that is the ideal goal or the holy grail that everybody seems to want to achieve in data center environments, right? But in practice, that's not possible. So we've essentially come up with these set of requirements, right? In general, the requirements that I have on these slides are driven by broadly three categories, right? Or I bucket them into three categories. One is real technical issues. The second is practical issues that appear in data centers because they're not typical vertically integrated systems like you would see on mobile devices, right? And the last is sort of perception issues that is that are there due to what people have seen in other server chip makers, right? So in general, so the requirements is that we want to minimize code in the secure world, the holy grail being that we have no code in the secure world other than say PSCI, right? And the reasoning behind that is lesser code in secure world, better the security, right? And this is where, historically where this, as far as I understand, where this comes from is x86 and SMM, right? SMM has been like the face of rootkits for many years, right? And for some reason, secure world is equated to, in some places it's equated to SMM, and the general feeling is don't put any code there. And So the goal is let's try and minimize secure world and not let's not repeat the mistakes of SMM, right? In general, that can fall into both the technical issue as well as the perception issue that we talked about. And the other thing is on server systems there is no known use case today for DRM or use of global platform APIs, RPMB and the like, right? Which is what you would typically see on mobile systems, right? And the more typical use cases are things like firmware first RAS handling, STMM, and secure storage, right? And this is not this is different from RPMB in that typically you can have like your flash controllers and things like that owned by secure world, and then TPM, right? And I say not always here because if you don't have DRTM, which some of you might be aware of, you might not even require this, right? But these are the typical use cases that we have in secure world, and if we can isolate this into the lowest privilege levels, it generally gives us better or could give us better security, right? So overarching goal, let's have as little possible as code in secure world, and if it is, let's deprivilege it as much as possible. The other is in data center environments, especially in the cloud environment, cycle stealing is a big deal. They're extremely sensitive to jitter, right? If you've got a secure interrupt, for example, and you take I don't know, a few milliseconds to process that interrupt, it becomes a big deal, especially when you're renting out processing power, right? That's just stolen cycles from customers. So in general, we want to minimize this in secure world. But there is no, at least as of today, practically there's no way to get away from secure interrupt handling, right? And we have to steal cycles. So again, the goal here is to minimize it, even though the ideal goal is this problem does not exist. And the other thing is, I guess this is common everywhere. There is no real scheduler in the secure world, right? And another, I guess, important point is that we typically don't have schedulers in the normal world that can be used to schedule, secure world apps as well, right? And I guess we can talk about that a little more. And then these two requirements is generally to move to the model where customers who really care about firmware at the highest privilege levels, we can tell them, hey, okay, we have everything that's upstream. It's long-term support. Everything is standards based. If you really want, go pick up code from upstream, modify it however you feel like, and run it on our systems, right? And the goal here is to minimize, standardize, and minimize hardware-specific secret sauce. And this seems to be the approach that groups like OCP, Open System Firmware, seem to be pushing towards, right? And so this we added this as sort of a requirement to try and achieve that. And the last requirement is, we want to have reusable solutions, right? So for example, if you take STMM, there is, lot of it is can be shared across platforms, right? There's not that much that is hardware specific. So if we can abstract that out using, some techniques like manifest or, using data or some discovery process, you can have portable and reusable solutions across, pre 8.4 and post 8.4 platforms. So, these were the requirements that we came up with and that we're trying to meet. Any questions on the requirements so far? Right, hearing nothing. And I'm here quickly jumping to this solution, right? And we can debate this as we go through the presentation. But we think having FFA secure EL0 partitions can enable us to meet some or all of those requirements, right? With FFA secure EL0 partitions, it seems like it's the simplest tool, right, to meet the requirements. And if we do this, we can avoid. And I say fully featured trusted OS here, right? I'll say why I say fully featured as opposed to avoid trusted OS entirely, right? We generally avoid tying ourselves to any specific trusted OS, because FFA is a spec and a standard, right? And if we don't have trusted OSs, it generally means, again, depending on who you ask, it's less code, which means less jitter, and less code can be approximated to better security as well, right? And since everything is in secure EL0, we also meet the goal of having better security because we isolate everything to the lowest privilege level. With secure EL0 partitions, we can have reusable solutions, since it's really EL0 code. So if I really want to run it on Opti, I can run it on Opti, and if I want to run it on some other trusted OS or some other thing like Hafnium, we can almost make it pick up the binary and drop it on a different OS and run, right? Although I guess we're a little ways from achieving that. And one other thing that FFA secure EL0 partitions does is it has a simple interrupt handling model for EL0 partitions. And this is a conscious trade-off we've made, I guess, between simplicity versus having extremely high efficiency for interrupt handling. So, on server systems, we do have interrupts like RAS interrupts, which are latency sensitive, in that we want to handle it as quickly as possible, but we don't expect very high volumes of them, right? So we think this is sufficient to meet those requirements, and we think this is a good trade-off to have. So we explored a few solutions, right? And this is really, if you're familiar with the FFA spec, this is pretty much, or at least 4 of the 5 are options that's supported straight up by the FFA spec, and it's really how we implement each of those options in the FFA spec, right? And we'll go through each of this, and in each of these I'll talk about the pros and cons. Now, the first one is, people can say, okay, why don't you just use a trusted OS? It's already got a good ecosystem. You've got lots of support already. Why would you want to, why not run FFA apps on secure EL0 partitions on a trusted OS, right? So this falls into, I guess there is a perception issue in my view with regard to trusted OS, that there is a large attack surface, right? And generally on server systems, people ask, okay, what is the use of trusted OS, right? Trusted OS is generally used for use cases like DRM, provide secure services, crypto services, RPMB, and use of global platform APIs, right? And there's no real known use case on the server side for these use cases, right? So it's hard to justify including a trusted OS. Now, and I'm taking Opti as an example, and this statement right here may not be completely accurate, right? But at least as it stands today, FFA support is in, say, Opti, for example, is limited, and it is being retrofitted, right? But I think conversation the last week or 2 seems that it's improving significantly and quickly, right? And I guess others on the call should be able to correct me here. The other issue with running FFA secure EL0 apps on trusted OS is that, and this is described really well in ARM's white paper for secure virtualization, right? And the white paper makes a case that in general, if we write a trusted a TA, right, you get tied to the trusted OS, and that's something that people want to avoid as well, right? Because if we get tied to, I don't know, Trustonic or Trusty or Opti or whatever, portability takes a hit, right? But whereas using FFA, that's just an ARM standard, right? So we're not really tied to any one particular vendor. So long as people implement this interface, we should have portability. And this, again, I say may because I'm not an expert here. Generally, we require trusted OS specific drivers, right? And for something like Opti, maybe this is completely upstream, but some other trusted OSs, this might not really be true. One of the other major problems that I personally see is, generally trusted OS has a history of being designed with mobile devices in mind, right? So if you look at say Ampere server system, it's got what 128 times 256 cores, right? So does Opti or these trusted OSs scale to hundreds of cores, right? I'm sure there are embedded optimizations in there to for various trade-offs, that might make this difficult to achieve, right? And these are practical concerns, right? The other is we don't know if we can, since this has a history, and there are a lot of people who have worked on creating this over the years. So there's always a question of can server vendors go and influence the design of trusted OSs to make it more friendly for these large systems, right? And in general, trusted OSs are compiled to a particular platform, right? But what on server systems are typically highly configurable systems, and the sort of the golden model that we would like to go towards is like the x86 Linux kernel, right? Just take an x86 system, download the kernel from kernel.org, and you just drop that in, and everything just magically works, right? So we're a little ways away from that for doing that, right? So and these are the pros and cons that I see, right? And some of them may agree with some of these, and some of them may not agree with these, right? So it depends on your viewpoint, because there are perception issues here in play as well. Any questions? So I guess the point I'm trying to make is, sure, we can use trusted OSs, but it's not exactly ideal on server systems. Now, the other solution we explored, right, is this is the age-old model around which STMM was designed, right? Have tiny dispatchers in EL3 and just have little to nothing in secure EL1 and just jump to secure EL0, right? And if we extend EL3 to have the FFA, and I believe there are patches in the works for this would actually be a really ideal solution, right? If you assume that we're putting bare bones code in EL3, this would be a super ideal solution. We don't have to go and defend to anybody saying, okay, there's a trusted OS, why do you need it? Or there's a large attack surface. Just exactly what is required for these apps to run in secure EL0. But again, this might be changing. As far as I understand, this is not really the main enablement model for ARM, and at least the upstream patches that I see currently only support STMM. And here, other ARM folks can jump in, but as far as I know, there's no plan to support multiple partitions in this model. And the other practical concern is that with ARM CCA coming up, the ownership model completely changes, right? If EL3 is, I forget what it's called, root realm, typically, I guess the expectation is it'll be owned by silicon vendor, right? But all of this can be owned by, say, a customer. So, if we put this in here, it's not really, it's not exactly an ideal situation to be in, right? If we can move it to something like EL1, then people can feel free to change it any way that they see fit. So again, this is a diagram from the FFA spec. This is one of the supported models.
Raghu, hey, Achin here. So yeah, just wanted to add, like, from a CCA perspective, basically EL3 is going to become root world and secure. There's going to be separation between EL3 and the lower exception levels in the secure world. And yeah, we do want the root world software to be absolutely minimal, right? So anything that runs today under the assumption that I'm running in the secure world would have to anyways migrate out at a very high level. So yeah, basically agree with what you're saying. Just wanted to add more color to that.
Yep. Yeah, there you go. So, even though we like the solution, considering the future, it's not, it's not a path that we can take forward. Thanks, Sachin. So, the next solution that we considered is, okay, on ARM, on ARM 8.4 plus systems, let's use Hafnium and trusted OS, right? This is already supported in upstream Hafnium. So why not? What's the problem with using this, right? So again, inside this, in this model, there are actually two sub-models, if you will, right? This is, again, you've got trusted OS and you've got the trusted apps, right? And depending on what trusted OS runs here, you've again got these apps that are tied to trusted OS, which we don't want to have, right? So all the reasons that apply to trusted OS applies within this box as well, right? So, again, it's the question will come up, why do you really need all this extra code for things that, for the use cases that we have in mind, right? And, in this sub model, one could argue, okay, sure, you have this, you put it in a VM and any, put your RAS firmware or your STMM firmware and run it in secure EL1, right? Why is that not possible? Sure, that is possible. We could do that, but it won't meet our goal of being easily portable between pre 8.4 and post 8.4, right? If you write secure EL1 code, if you don't have virtualization, in our ideal goal of having binary compatibility for all of these use cases like RAS and STMM, that'll be much harder to achieve. And again, another question that we get asked is, okay, do you really need virtualization in the secure world, right? We're still hearing from some of our customers that we really want to have the EL3 SPMD plus SPMC model, right? Because there is again this perception that anything that goes into say secure EL2 or secure EL1 is going to be bloated, or for whatever reason, right? They don't even want to have secure EL2 in there. So, we're going to get asked the question, do you really need virtualization and all that complexity? And if you look at ARM's secure virtualization white paper, one of the things is, to enable the need to run multiple trusted OSs, right? And given our use cases, we don't really need to do that, right? And if we ask ourselves the question, can we achieve our use cases without virtualization? We see that the answer, at least for us, is yes. And not to mention that virtualization has its overhead, right? So if you've got two stages of memory, two stages of translation, and if there's a TLB miss, that's potentially 16 memory accesses on a TLB miss, right? And this contributes to jitter, which server customers tend to be more sensitive about, right? And again, when we have to context switch, if you've got multiple apps, right? Say you've got a RAS app and you've got a STMM. I keep saying app, but I really mean partition, right? You've got a RAS partition, an STMM or a TPM partition, right? If you have to context switch between the two, say while interrupt handling, it's a larger context switch, right? And some of the numbers I've seen is, to switch a full VM is about 3 times more expensive than just switching EL0 context. So there are some overheads, and given the jitter sensitivity, the question is, can we avoid this? And with the other solutions, I think we can avoid it. So one other solution that we did consider is, okay, sure, you don't want to trust OS, right? Why don't you just put a shim in here? Why don't you use Hafnium's existing support and run this as a VM? And when we looked at it, this again seems like a acceptable solution, right? But it has the virtualization overheads. Let's say we are okay with living with that. Then we still have the problem of, so this becomes a little weird, right? Because you've got a partition that's written with the secure EL0 model in mind, but it really is a secure EL1 partition. And, this is a VM from Hafnium's point of view, but is treated as a secure EL0 partition from an interrupt handling point of view, right? If you look at the FF-A spec, there are a few differences in the interrupt handling model. So this is sort of an in-between solution, right? So sure, we can have the solution, but when we started looking at how would it look if we implement it, there were some issues that were highlighted, right? Both that we did, and some folks from ARM as well did right now. So some questions were, okay, where will the shim live, right? Is it going to be a part of the application, or should it be a part of Hafnium? If it's a part of Hafnium, then Hafnium needs to have code to recognize these partitions that are sort of in between, and supported differently, right? And if this is a part of the build of the partition as opposed to Hafnium, now different vendors who supply this could have different implementations of the secure EL1 shim, right? So is this solvable? I think yes, but is there a cleaner solution, right? And hopefully, as we see VHE, hopefully you can see that that seems like a cleaner solution, right? And then there's another interesting use case with FFA memory management, right? When if you've just gotten a S-EL0 FF-A partition, if there's a memory management transaction, in an ideal world, all it does is use the FFA ABIs, right? But now when you've got the secure EL1 shim, any of those memory management calls need to be intercepted here, or potentially intercepted here, and we need to have some stage one management, stage one MMU management here, right? And then stage two is managed by the secure EL2 SPMC. So there's some ugliness around that. Again, it's not unsolvable, but if there is a way to avoid that, why not avoid it, right? So I don't want to get into the details of this, but there are some nuances to the memory management aspect. So this again is a reasonable solution, but it seems like having the next solution that we'll go to seems like a better or cleaner approach in the long term. So now we'll get to what I really wanted to talk about, right? And that's using VHE with Hafnium, right? So for those of you who are not aware of what VHE is, it's just a very quick primer, if you will, right? This on the left side is your typical virtualize or a typical ARMv8.0 virtualization model, right? You've got applications that run on top of guest OSs, and then you've got multiple guest OSs, and depending on how the system is designed, you typically have host OS, right? And then the hypervisor runs in EL2. Now this has some pros and this has some cons, but from a performance point of view, this is generally seem to be slower, right? So with this model, the hypervisor has to reinvent some of the things that exist in the host OS, such as scheduling or memory management and things like that, right? And VHE enables us to move to this model on the right side, right? Where this host OS here just simply moves over to EL2 unmodified, right? You still access say EL1 registers, but with VHE enabled, it just gets redirected. So what this means is, firstly, performance is improved, and I'll show you on the next slide how at a very high level. And then the second thing is you don't have to reinvent some of the things that you already do in an OS like Linux in the hypervisor, right? This guy can mostly be about isolation and running context switching VMs and things like that. So this is what VHE at a very high level enables, right? And if you can see, this E2H bit enables VHE, and then when there's another bit called TGE. If it is 0, you go back to the model on the left side, and if it is 1, you go to this model on the right side, right? And so this enables the Linux KVM model, and as far as best as my understanding is the x86 virtualization model as well, right? Where they have a root mode and non-root mode for virtualization. And this slide here should help understand the performance aspect of it, right? And I took this from a nice presentation that was in, I think, Linux Foundation or perhaps even Linaro, I don't remember. There's a link here. So in the ARMv8.0 model, the way Linux and KVM used to work is you had Linux running in EL1, you had this KVM driver, if you will, and then they had a low visor that runs in EL2, right? And most of the logic lived here, but they had to make hypercall and returns here to, to context switch VMs and things like that, right? So this is really the overhead that is avoided when we move to this model, right? And the real advantage is you can run unmodified Linux in EL2, right? It literally says, yeah, SETLR, EL1 and things like that, but it's actually running in EL2. And so this is how VHE improves performance. And so this is just a brief primer on what VHE is, right? And now if we move to, and if you have any questions, please feel free to stop me.
I have a question on the previous slide.
This one?
Yeah, I think, oh yeah, on the second approach, I mean, it's more convenient, but do you think it's maybe a bad decision in regards to security? Now you have the Linux kernel running in EL2, a more privileged level.
Yes, it is, right. Yeah, you've got more privilege level, you've got more, but for at least in the normal world where where it's more of a rich execution environment, it seems like the priority is more to not reinvent existing functionality, for example, in say EL2, right? I know there are other models that you can use, but this is following from the x86 model, right? If I have all of this code, all of the scheduling, memory management logic already, and I could just magically run it at EL2 and still manage VMs, it just reduces development effort and things like that. From a security standpoint, yeah, I guess I agree with you that it might not be the greatest idea.
Yeah, okay.
So yeah, with Hafnium, your point is very valid, right? And I guess I hope I can explain why that is, that's not really a problem for Hafnium, right? When we discuss this. So this is really the solution that we think is a nice long-term approach to enable secure EL0 partitions on on ARMv8.1, right? So today's Hafnium model is exactly like this one, right? That's on the left side. But the model that we want to move to is really here, right? Is this right side model. The main difference, between say Linux and Hafnium in the secure world is get rid of this blue box. All we have is this green box portion of it. That's what it really is, right? Because there is no, Hafnium does not have scheduling, not much memory management other than, I guess say MMU management and maybe a little bit of memory allocation, right? So it's just we move from this model to this model minus all of this junk. So really you haven't increased your TCB by much, and hopefully, in the next couple of slides, we'll get to that. And you can still run, VMs, that's your secure EL1 partitions. And you can also run, you can run your secure EL1 partitions, and you can also run the secure EL0 partitions, right? And we think that's a good approach to enabling secure EL0 partitions, right? And this is sort of contrasted with all the previous solutions, right? So one is, there's explicit support for this in the FFA spec, right? So this is not something we are doing out of spec. And one of the advantages of Hafnium, relative to trusted OS that I haven't talked about is that, it's explicitly built with FFA in mind, right? Mostly, and I say mostly because I believe there's some history with Google, but I'll ignore that for the moment. It's built exclusively with FFA in mind. There's not much legacy involved in there at all. And this using something in secure EL2 is a better model given ARMv9 CCA changes that are coming in, and what Achin said before. And for we only really need secure EL0 partitions for our use cases, so we can avoid this virtualization overhead that we talked about before. And there's no legacy that I alluded to, so in theory, it has a lower attack surface. And again, given that there's not much legacy of mobile around it, there's a chance for folks like us to influence scalability, right, for large systems. That and this is something actively I'm trying to do with the upstream community for Hafnium, right? And this can, the flexibility can be seen as both as a pro and con. You could run secure EL0 partitions and secure EL1 partitions if somebody so chooses it, right? And for this, we need VHE support. Without VHE support, you're pretty much limited to secure EL1 partitions, right? Now, one of the questions that I've been asked and I've had debates about, right, is how is Hafnium from VHE any different from a trusted OS? If you ignore this part on the right side, and you only look at, if I draw a box around this, really, how is it different from a trusted OS? And my answer to that is no, it is not. It's not different, right? What really is different here is, again, this goes back to perception, right? VHE really turns Hafnium into an FFA only trusted OS. Right? There's no legacy. You're basically eliminating all the legacy, and having the ability to potentially influence scalability for large systems, right? That's really what it's doing. And sure, if somebody wants the flexibility, it can also be a hypervisor. And to address the question that I don't know who that was from the voice, but from a security standpoint, especially for Hafnium plus VHE, we are not really increasing the TCB, right? It's just we are adding a few register bits, and I can in the next slide, hopefully you will see, in the next few slides you'll hopefully see that, right? We're not really bloating the TCB because we're not implementing any memory management or scheduling or anything. It's just whatever exists today with some extra code to enable VHE, and then secure EL0 partitions just magically work just like secure EL1 partitions.
Raghu, speaking of perceptions, just the way I look at it is that whenever we speak about VHE, the first thing that comes to mind are like the type 2 hypervisors like KVM and such. And one of the fears is that, all right, we're basically stuffing the entire operating system inside EL2. That's what VHE was originally meant to do. But in this case, what we're effectively saying is that we have a type 1 partitioning hypervisor, which is only responsible for isolation using generic drivers, right? Hopefully as much as possible. But traditionally, where a type 1 partitioning hypervisor has dealt with secure EL1 or say EL1 VMs, now it has this added thing that it only has to deal with EL0 entities. So we have basically, as we have discussed previously, it's taken an entire exception level out of the equation. So type 1 hypervisor, type 1 partitioning hypervisor, which only deals with secure EL0 VMs, is might be just another way of looking at it.
Absolutely, yes, correct. Right. So yeah, I think Achin's point is very important, right? So there shouldn't be any perception that this is somehow bloating the TCB beyond what Hafnium already has, right? So if you look at the patches, you should see that it's fairly, at least in my view, very surgical changes, and it's very low impact changes to enable this, right? And there's no real extra functionality that we've added to enable this. It's really setting a few register bits and having a couple of if-else's in code, where it says, okay, if there's VHE support, do some of this, and that's around TLB invalidation and things like that. Otherwise, it's at least in my view, is a very low impact change, and it does not impact or increase your TCB, right? And that's another attractive property of this. So now, hopefully I've told you all the good things of.
Raghu, I have one question. So updating Hafnium for VHE configuration, I think it is as similar to updating Hafnium for EL1, basically running Hafnium at EL1. So just wanted to understand why we updated Hafnium for VHE, not updating Hafnium for running at EL1.
Well, I mean, that would, so if I have to rewrite it for EL1, then I have to go change all the references to registers that say underscore EL2 to underscore EL1 and live with, and, you know, pretty much change the code to make it run and secure EL1, right? VHE is really just setting a couple of bits in the architectural registers, and you can run an unmodified EL2 unmodified EL2 code or unmodified EL1 code.
No, I think it runs guest OS unmodified at EL2. So whatever the EL1 registers will be indirectly translated to EL2. I think it's the other way around.
Well, I mean, no, I don't know. I've done the POC, and Hafnium is all written for EL2, right? And it has all the registers, you know, all the register access are EL2. When you enable E2H, it, you know, the semantics of the EL2 registers become equivalent of the semantics of the EL1 registers. Or if you've written code to access EL1 registers, it gets redirected to the EL2 registers, right?
Yep, I think it's safe to say that there's more architectural support to make Hafnium and Secure EL2 handle Secure EL0 apps rather than pushing it one exception level down to do the same thing. That's again, like, I haven't, like Raghu, you are the one who's been down in the trenches, but yeah, that's my understanding too.
Correct. Yeah.
Raghu, would be also like pushing Hafnium out of the TCB, right?
How's that?
If you move it to Secure EL1 instead of EL2.
Not really, right? So it depends on then what runs on Secure EL2. If you disable Secure EL2, it's the same code that, you know, say runs in Secure EL1.
Fair enough. If you disable Secure EL2, yeah, okay.
Right.
Raghu, Olivier there. You mentioned in an earlier slide one of the concerns with trusted OSs meant for mobile the problem of scaling to hundreds of cores. I'm thinking that Hafnium might have the same scaling problem when you consider many cores. Do you have some plan or ideas in mind to improve Hafnium in scaling to large many core systems?
Well, some yes, and, you know, I hope to talk to you or like engage with you on upstream patches to try and do this right. You know, for example, some of the things this is not exactly for scaling, but, you know, for example, you know, the SMMU base addresses, right now is a build parameter, and if you remember, I said we want the console, you know, all these address map things to really be part of the manifest as opposed to build, right? So that will enable Hafnium, for example, to just be built generically and dropped into any ARMv8.4 systems. But yes, for you know, for scaling, yeah, there are some thoughts I have in mind that are not yet quite well formed, right? Especially when you start considering multi-socket systems and things like that. But yeah, it's not really, I wouldn't say it's well formed at the moment, but I guess maybe expect that to come.
Yeah, I'm thinking there is some work to do around locks, spin locks, because this is
exactly
a simple implementation that we have.
Right. Yeah, that's one of the, so for example, in the, you know, in the notification patches as well, you know, I recently suggested that maybe we can make the locking a little more finer grained. So you know, that might help with scaling to larger systems as well.
Yeah, exactly.
So things like that, right? So as and when I see, I will do it. But, you know, some of the things that are like static, you know, like the max number of vCPUs and things like that, yeah, we really need to carefully consider how to scale them up. And you know, one of the differences with Hafnium versus trusted OS is given that Hafnium is a little newer, I think it should be easier to influence Hafnium than it would potentially be, say, to implement, I don't know, Trusty or Opti or Trustonic or something like that, right? Since they are hyper focused on other use cases. And I know the focus even for Hafnium is mobile, but I feel like there is or the perception is there's a better chance to help it scale.
Okay, thanks.
All right, I just have a quick couple of slides. So yeah, Hafnium plus VHE, touted all the good things, but it doesn't come for free, right? Now there were concerns around maintenance and support. Now we need to, support this extra configuration. We need to maintain the support for it and test it and make sure, secure EL1 partition, any changes for that does not break secure EL0, right? So it's not free of cost. And then, for the interrupt handling for secure EL1 partitions by design in the FFA spec is more efficient than secure EL0, right? So, this, depending on your use case, this might become a problem, right? For us, I think for the use cases we have in mind, we think it should be okay. But, it's not to say we might not run into this, right? And a quick difference is that for secure EL1, since there is virtual interrupts, you can inject interrupts at any time into the partition, right? Whereas for secure EL0, it's really just a message loop. So, only one thing can be going on at a time in a given execution context. So depending on the use case, this could be a problem, right? And even with secure EL0 support, there is some increase in code size, right? And I wish it was like 0 lines of code and have magical support for this, but there is some code that is required for this. And initially, we will likely have support for both secure EL1 and secure EL0 partition, right? So in an ideal world, we would have a Hafnium configuration where we can compile out support for secure EL1 and only have support for secure EL0 partition, right? But that's so for now, this is again not an ideal situation, but it's still, I suppose, better than some of the alternatives that we have in mind. And this is for once the slides go up, this is for folks to stare at, right? I have put each of the solutions in the rows and against the requirements in the first slide, and sort of filled out a table that should summarize the entire presentation, right? And depending on your viewpoint, you may or may not agree with some of these things, right? Because there's perceptions involved here as well. But I think for folks that are interested, I think this might be a good summary of the presentation to have a look at. And quickly on, so I've pushed patches for the proof of concept, and I guess some of the patches are beginning to merge. And there are approximately 40 patches, right? And it's 40 patches because it's I think about 10-15 of them are probably just related to tests and some of the things that we're trying out. And the other 20-25 patches are really very surgical changes to Hafnium, right? It's not big giant patches. And this is all upstream, so folks can go and take a look at it. So in terms of testing, one of the things that's done in the POC is that really the intent of this was only secure EL0 partitions, right? But given where Hafnium was in the test infrastructure support, I initially did all the support for VHE in the normal world, tested it on QEMU, and then moved over to secure EL0, because really the only difference between the two is the NS bit, right? And then I tested the secure EL0 partitions on FBP, and approximately ported 75 test cases in the normal world to test out to make sure it's not causing issues for the existing use cases or for the new use cases. So there's a decent bit of testing that's done. There's plan to add more, and then there were concerns about, okay, what if, how do we revert these changes if if there is code rot? So one of the things that's done is all of them are labeled with VHE. It's under a build flag. And this pretty basic stuff. So if it really starts rotting, you can just grep for VHE and just revert those patches, and you should be left with the vanilla Hafnium. Some of the opens, I think the first three are the biggest opens. This we are actively discussing. One of the things that's done is, the way currently things are done is I'm mapping the entire secure EL0 partition as RWX in the MMU from Hafnium, right? And that's that's really less than ideal. And it says tooling issue, but it seems like it might be a bigger issue than that. We need to figure out how to pass information, say, to Hafnium or the SPMC in general, to be able to map an EL0 partition, with the minimum required permissions, right? And frankly, without fixing this, I don't think it should ever be used in reality, right? The other thing is, I touted the context switch and jitter. The reality is today, even EL0 partition switches EL1 state. Even though this is not required, right? Just from a code path point of view, I need to add a few checks to make sure I don't need to switch this to make the context switch more lightweight. And really, how EL0 partitions are modeled today is as a vCPU, except that when you set TG equal to 1, all of this is really zeros, right? But it still gets switched and gets written to 0. So this is again less than ideal. And we need to figure out secure interrupt handling support. And test code has a whole bunch of duplication that needs to be cleaned up. Then, like I said in the previous slide, can we do a purely S-EL0 Hafnium? So this is the status of the POC, and I think that's pretty much my last slide, and then I'll open up for questions as well. It seems like we only have 4 minutes. Yeah, so takeaway is, encourage other ARM vendors to see if you can use secure EL0 partitions, and please review the patches that are upstream. And this is something that would be nice to have this trusted services project. If we can run it on Hafnium using VHE, that would be validation that this is a nice tool to have, right? And lastly, I want to thank these three guys here. Spent a lot of time over the last year discussing this, and sort of a result of all the efforts and contributions these guys have made. So thanks to you guys. I guess we have 3 minutes or 4 minutes for questions.
Just one comment about the initial tests that were made for EL0 partitions in the normal world. Mm-hmm. So while I understand it's a nice test harness, it's very much an option which is not present in the spec.
Correct.
So in the midterm, do you intend to really restrict to S-EL0 partitions and, well, in a way, remove the support for EL0 partitions? I mean, NS-EL0 partitions.
I mean, I'm happy to do that, right? This is just really a tool for me to test out all these things, and I'm more than happy to keep this as private and remove support for this, right? And most of the impact over here is really on the test side, right? Within Hafnium, I think there's nothing that needs to change.
Yeah.
So if this is bloat, I can get rid of it.
I'm more thinking in terms of, well, really matching the spec as it is describing things, because this adds for example, an option in the manifest or override some option in the manifest to take care of NS-EL0 partitions that should not exist. But yeah, I understand from where it comes from.
Yep. Yeah, we can get rid of that. I'm happy to keep that private. I just pushed that to, I guess, to show that, okay, this is possible, but yeah, we can work with upstream to change it as we see fit.
Yeah, in the opens, the PSCI interaction is really a very long running discussion that we've had since 1 year and a half. So the FFA spec now has a guidance, but I didn't figure out how does it map S-EL0 partitions requirement.
Yeah,
so
I haven't done that either.
Well, I understand how it works for partitions with multiple contexts, vCPU contexts. Here with S-EL0 partitions, I'm still unclear about what do we want to do for S-EL0 partitions and how does it work when there is a unique vCPU. So a bit of guidance and clarification from NVIDIA is welcome here.
Yeah, at least we haven't really talked about this much. So yeah, this is again on, I guess, one of the things amongst all the other things that we need to figure out.
Hi, here's Lucas from Trustonic. So I'm wondering, is there some kind of deadline or when you need to, or some kind of production plan for all this? Because it seems kind of in the beginning of a project, so you have something working, proof of concept. So that's kind of question one. And the second question is, do you think all these secure partitions, they will need some kind of common services or let's say access to a secure time or what if secure debug, these kind of services that the simple kind of restricted Hafnium version, Hafnium hypervisor would not have today? And maybe third question, what do you run in the secure partitions? Are these things that are necessary for the platform, or is it the VMs that can run their own secure partitions, something like, yeah, each client, they run some VM and each VM comes with some secure partition? So okay, that's my questions.
Yeah, to the first question, timelines, yeah, I obviously cannot, say anything about timelines, right? But yeah, we want to actively work with the upstream community and get this merged. So in terms of secure debug and some of the other use cases you mentioned, so far no, we don't know of any such use cases. Really, if I go back to slide 3 or 4, the real use cases that we have are standalone RAS, and maybe a TPM app, right? And these are like well-known use cases in the upstream community, right? Like STM already has code. We don't have any use cases as of now for things like secure debug. And I think your third question was about platform code. It depends on what you define as a platform. So if you mean the SOC, yes, there is some SOC specific stuff, and I look at platform as things beyond the SOC. So there is some platform management aspects too that we want to run as secure EL0 partitions, right? But in general, it's fairly different from what we typically see in say a mobile device. Does that answer your question?
Yes. Okay. Basically, what you said, the TPM or the RAS or the STMM, those are the kind of platform services for me that must be there in the platform from the beginning. But correct. You don't support kind of loading dynamically secure partitions that you might need when some customer of the VM farm, of the server farm, installs a new VM or something like this.
Correct. And I think we are being explicitly told we don't want all those functionality, right? Or at least that's what I have taken away in the last few years of doing this.
All right.
So one of the opens, Raghu, can be the SMMU driver. This really doesn't apply to this, but I mean, it applies to all the methods.
Sorry, I couldn't hear that. Mayur, say that again.
The SMMU driver.
Mm-hmm. Oh yeah, that would be one of the things too, right? Yeah, one of the things we might need is that's an open as well. We have to have support for SMMU stage 1 driver to be able for these secure EL0 partitions that may need access to a device. That's something that we are planning to work on as well.
Maybe another question. Do you need secure? You said eventually in the beginning secure storage. So I guess you have cryptography and maybe a secure file system. Yeah.
So we don't have requirement for secure storage is really very simple, right? The only real use case is if you run UFI as the bootloader, we want secure storage for secure variables. Beyond that, it's not like we need RPMB or the typical mobile type of secure storage, right? And yeah, we don't really need crypto services that are locked down to trust zone, right? Typically those SOCs just have crypto accelerators exposed to normal world. Here you guys just go use it.
Okay, yes, very interesting. Thanks.
Yeah, so that's
So,
why it's driven by
Raghu,
data
we
centers.
have
It's a
a
little different.
FFA ACS.
Go ahead.
Sorry, you want to finish? Or?
No, I'm
Okay,
done. Go
so we have a FFA ACS. Okay, so we have a FFA ACS where basically ACS provide us 3 secure partitions which can be integrated with the SPMC. So I think you may basically want to run ACS with your solutions in order to verify your solution.
Yes, I don't know if my colleague Varun is there, right? And I don't know, Mayur as well, you might know. So yes, there is some plan to use ACS. And yeah, if it is upstream, yeah, I'd like to use that to validate this whole solution as well. That'd be great. Yeah.
Yeah, we're looking into it. That's in the plans, but nothing concrete yet.
Is it upstream? I saw some patches recently, for the ACS getting upstream into TFTF. If that makes it in, then yeah, absolutely. I think it'll be great test suite to run.
So we have a different repo for the FFA ACS. So at the moment we have a alpha release that is externally available. But this week we are planning to have more test cases upstream, and that would be a beta quality one. So once that is upstream, I think we may basically let you know the release detail.
Oh yeah, that'll be very helpful. Yeah, if we can run ACS against secure EL0 partitions, I think that'll be really good on Hafnium.
Hi, Raghu. Subi here. Just for the sake of completion, it was not clear to me how this VHE solution enables you to run the same partition on a pre-V8.4 platform. Could you mention that for the sake of completion?
Yeah, I mean, so really the portability comes from the fact that it's running in EL0, right? On pre-8.4, the assumption is, you have a trusted OS, and if you've got a trusted OS that supports FFA, all the code in EL0 is really FFA ABI calls, and any other EL0 code, right? There's no real EL1 code or MMU management, none of that. So if you build a binary that's purely FFA based, in theory, you could compile it and just drop it into either one of those platforms. Sure, if there are platform specific stuff, you might need to recompile, but even that, you can avoid the recompile if you abstract it out using things like manifest, the usual techniques to abstract out platform differences.
Okay, so in this case, the SPMC would be a S-EL0 SPMC, which is not Hafnium, but some other SPMC, right?
Correct. Yeah.
Yeah. Okay. Thanks.
And in theory, I could take STMM, abstract out the platform differences. If I have a discovery interface, STMM just discovers it. It's the same binary, but I just take the same binary, drop it in on, say, an Opti SPMC or Hafnium SPMC, and it just magically works, right? It's not quite there yet in reality, but it's their goal.
I guess it's really about adopting the standardized IVA from FFA, meaning the same binary can run whichever the SPMC solution because the IVA is the same. I think that's the beauty of it.
Yep.
Okay, thanks.
Anything else? Yeah, if not, I'm done. Joanna, guess you can take over. Thanks so much for letting me present.
You're welcome. I've got all the questions and answers recorded, so if any of your colleagues missed them at the end, once I've published the details and trustedfirmware.org, people can review them. Yeah, so thank you everyone. We've overrun by 10 minutes, but that's no problem. Thank you, Raghu, for your presentation, and I wish everyone a good day.
All right, thanks all. Bye.
Thank you.
Bye.
Thank you.